Now come to the question number 13. Question number 13. If x plus y plus z is equal to 0, if x plus y plus z value is 0, show that x cube plus y cube plus z cube is equal to 3xyz. We have to prove this statement. Understood the question, my dear children? Right. We know that the identity, eighth identity, with the help of eighth identity, we prove the statement. Okay, my dear children? Right. X cube plus y cube plus z cube minus 3xyz is equal to x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. This is nothing but eighth identity. You have already learnt well. I hope you have learnt well, my dear children. Right. So in this algebraic identity, we put x plus y plus z is equal to 0 because it is given that the value of x plus y plus z is equal to 0. That is why I am substituting the value of x plus y plus z is equal to 0 in this algebraic identity. Okay, my dear children. Then we write LHS as it is because there is no x plus y plus z. So we write LHS part as it is equal in RHS in this brackets you got x plus y plus z. We got that expression. So we replace this expression by 0. We replace that x plus y plus z, that expression by 0. Into, we write this algebraic expression as it is, that is x square plus y square plus z square minus xy minus yz minus zx. Understood this step, my children? Just we have replaced x plus y plus z by 0. Understood, my children? Right. This implies x plus y plus z, x cube plus y cube plus z cube minus 3xyz is equal to, what will you get? 0 into any number, 0 into any expression. Finally, you get 0. Understood, my dear children? Right. If you move minus 3xyz to RHS, how it become plus 3xyz? So this implies x cube plus y cube plus z cube is equal to 3xyz. Understood this step, my dear children? Right. This is nothing but we have to prove that statement, the required statement we have proved here. Hence, proved. Understood, my dear children? Any doubts? Right. Now, come to the question number 14. Roman number 14. In this Roman number 14, there are two parts. There are two questions are there. Both are of the same type. Both parts are of the same type. So, I am explaining second part. I am explaining second question in the Roman number 14. The first question is also that of the second question. Okay, my dear children. Can you do it? First question, my dear children? Right. After completing this one, you try the first question in this Roman number 14. Okay, my dear children? Right. Without actually calculating the cubes, find the value of 28 whole cube plus minus 15 whole cube plus minus 13 whole cube. Understood the question, my dear children? Without finding 28 whole cube separately and minus 15 whole cube value separately and minus 13 whole cube separately and by adding them. We should not follow that procedure here. Without actually calculating the cubes, it is mentioned clearly. Then we use algebraic identities. Okay, my dear children, here now given expression, that is 28 whole cube plus minus 15 whole cube plus minus 13 whole cube. we observe this expression. If you observe this expression, it is in the form of a cube plus b cube plus c cube. So by comparing this expression with a cube plus b cube plus c cube, we get a is equal to 28 and b value is minus 15 and c value is minus 13. Understood this part, my dear children? Right. And also we observe that if you observe here a plus b plus c, if you find the sum of these three numbers, what will you get here? 28 plus minus 15, b value is minus 15 plus c value is minus 13. That is equal to, just I substituted a, b and c values. We are going to find the value of a plus b plus c. Then what will you get here? 28 minus 15 minus 13. That is equal to 28 minus 28. What will you get finally? 0. So here we observe that a plus b plus c is equal to 0. So in the previous question, we got the result. If a plus b plus c is equal to 0, then a cube plus b cube plus c cube is equal to 3abc. Okay, my dear children. So we know that if a plus b plus c is equal to 0, then a cube plus b cube plus c cube is equal to 3abc. We have proved it. Okay, my dear children. Right. This implies in this equation we are substituting a, b and c values. What is a here? A is equal to 28. So 28 whole cube plus b cube minus 15 whole cube plus c cube minus 13 whole cube is equal to 3abc. 3 into a means 28, b means minus 15 and c means minus 13. Understood this step, my dear children? Right. Now by multiplying these three numbers, what will you get? Minus 16,380. Understood, my dear children? Right. So finally what will you get here? 3 into 28 into minus 15 into minus 13. Finally positive number, so 16,380. It is the value of the given expression. Okay, my dear children? Right. Now come to the question number 15. Question number 15. Give possible expressions for the length and breadth of the rectangle with the area 25a square minus 35a plus 12. Understood the question, my dear children? We have to find the factors of this quadratic polynomial. It is an indirect question. They did not ask you factorize this quadratic polynomial 25a square minus 35a plus 12. Okay, my dear children? They asked the question like this. We have to find length and breadth, means we have to find the factors of this quadratic polynomial. So given area of a rectangle is equal to 25a square minus 35a plus 12. You know how to factorize a quadratic polynomial. So I am not explaining the steps in detail. Okay, my dear children, I am writing the steps directly. So 25 into 12, in the rough work I am finding the product of these two numbers. 25 into 12, you get 300. For this number I wrote the product of two numbers as many ways as possible. These are the possible ways. Out of these we have to get 35. Where will you get 35? Here 15, 20. We use these two factors. we split the middle term. Okay, my dear children. So 25a square minus 20a minus 15a plus 12. Here we are using the splitting the middle term method to factorize a quadratic polynomial. Remember that process. Remember the steps, my dear children. Okay, right. And now there are four terms. From the first two terms, we can take out 5a, that is common factor. By taking out the common factor, you get here 5a minus 4. Okay, my children, understood this term? Right. Now, from the last two terms, from the third term and from the fourth term, we can take it minus 3 as a common factor. In the brackets, we get 5a minus 4. Understood that term, my dear children? Right. Again, from these two terms, 5a minus 4 is a common factor. So, by taking out this common factor 5a minus 4, what will you get here? 5a minus 3. So, here we got the factors of the quadratic polynomial. This is length and this is breadth. What is the formula for area of a rectangle? Length into breadth. So it is length and it is a breadth, or this is length or this is a breadth, because we don't know their numerical values. Okay, my dear children. Therefore, finally we write this step. Therefore, possible expressions for length and breadth of the rectangle are 5a minus 3 and 5a minus 4. Understood, my dear children? Right. Similarly, one more quadratic polynomial is also given in the question number 15. Will you try the question number 15, third, second part? Okay, my dear children? Right.